Hi, my mom's going to be teaching about radicals. Miss Baker.
Okay, thank you, Jennifer. Okay, welcome to
Thank you.
Baker Online School.
Thank you.
Okay, this first lesson is going to be just a little trial. One of the teachers told me I could record from my Chromebook, so I'm trying that, but I don't know if it's going to be large enough, so any feedback you want to give me is great. Your first assignment is to print out this handout from home, and you're going to start filling in the notes as I go through them, and then your homework is going to be to finish. All right, so let's see how we can do this so you guys can see everything. Okay, so the notes are about simplifying radicals, and we've already done this plenty of times before, especially when we were doing the quadratic formula. But today we're going to add in a little bit more complicated step because we're going to use variables inside the radical as well. Okay, so just to review what we did in the past, if ever we had to simplify something like square root of 54, is we broke it down into all its prime factors. So I'm going to start with 54 up here, and then I'll use my little prime factor tree, and maybe I'll just do 9 times 6. Okay, and so in the notes there's a box that says multiplication property of square roots, and basically it says just this, that you can take a value, we'll say something like a times b, and you're allowed to split it up into two separate radicals, so it would be the square root of a times square root of b. And both of those represent the same value, and so that would apply to this problem because I could think of this as the square root of 9 times the square root of 6 instead of the square root of 54. But the way that we've sort of learned how to do it is just taking it a step further, and we keep breaking it down into all the prime factors. So 3 times 2, and then we circle. Okay, so I'm going to pull out the square root of 9 because I have a pair, and so we know that we can take out the 3 since they have a pair, but also that's what the square root of 9 is. It's 3. And then any values that did not have a pair means they're not a perfect square. So I'm going to leave those inside the radical, and then I need to multiply them back out to what they were, which was 6. So that would be our simplified answer, 3 root 6. It's the exact same value as square root of 54. Okay, so then below it says list of perfect squares. So we're just going to take the number above, and then if we were to square that number, we're just going to put that answer down below. So 2 squared is 4. 3 squared, 9. And so on. So if you want to keep going, I'll give you a minute to do that. Four squared, 16. 25. 36 is, or 6 squared is 36. 7 times 7 is 49. 64. 81. That one's easy, 100. The ones down here are a little harder, so you might need a calculator, or you could just multiply them on the side. 11 squared is 121. 12 squared, 144. And that's usually where it stops, where people kind of stop memorizing the squares. But 13, because it ends in a 3, so 3 times 3 is going to be 9. So this one's 169. This one, 4 times 4 is 16, so it's going to end in a 6. This one's 196. That one is 225. I kind of forget 16 squared, so I'm going to skip over it because I think I know this one, which is 289. I know 20 squared, that's 400. And then let's see if we can figure this out on 16 squared.